Okay, this today we will go for what is structural analysis. What is a structural analysis? What is it? We study structural analysis. Study about. Okay. What's
study of and their
good? Good. Introduction. Structural analysis.
analysis
Yeah.
the
Combination of loads. Dealing with loads. Structural analysis. Go ahead. Civil.
Yes.
Go ahead. Civil. Did you have the hard copy? No? Tab ask for hard copy now, please. Did you have hard copy for our exercise? Perfect. Okay. Structure analysis, guys, is what? Focus. Let us focus. Is what? Is a determination. Let us see what is the determination of what? Is a determination of the effect of what? Of loads on a physical structures and physical structure and their components. Is the determination put under determination many lines and effects and loads and physical structure and their component. See, when I said now, we are existing in what? Now, existing in what? We are existing in what? Now, we have a conventional system. This is structure is a conventional system. Means what? Concrete, slabs, beams, columns, footing, soil. Now, what is the load now? What is the load? Now, physical structure is a lot of type of physical structure. A stadium, bridges, warehouse. Just physical structure. We have load. This loads. What type of loads? We have very important two loads. Is live load, and we call it in our right. When I say load, means the live load plus dead load. There is wind load. There is thermal load. There is in our and the live load and will not go for snow. What system? It's not coming in our exam. Why is it coming? Because our exam is very simple. Very simple. Now we have loads. They have effects. What is the effects then? Loads. Loads is already loads. Loads. What is the effects of our loads? What is the effects? Help. But we are already external life. Already external. Why? Because after a while, 7.
Yeah.
Go ahead. Did you have the exercise?
No,
Brent, yes. We are after the class, we all of us will go home. Huh? Class. There is no effect. There is no effect. Correct? So what is the effect? Normal force, shear force. We call it develop what? Develop what? يلا يبقى now we have normal and we have shear and we have moment. Only deflection. It's a effect. What else? Yes, perfect. Good. Welcome. What else? What else? Stresses. Stresses. Correct? No stress. Sheer stress. Stress. We are going to determine what? If you have external load, we need to determine what? Determine normal, shear, moment, stresses, and equilibrium. And equilibrium are this thing stable. Assumption. What is the assumption? What is assumption? That every structure analysis is stable under equilibrium. Means what? Moment at any point in a structure element, physical structure and their component. Their component. What's the component of this physical structure that we exist now? What's the component? We have Alaykum Assalam. We have one, two, 3, A, B, and C. A, B, and C. We have 4 meter and we have 2 meter and 2 meter and 4 meter. When I told you now, there is a column here and there is a column here, and there is a column here, and a column here, and a column here, and here column, and here is a column, and here is a column. So then what is this element here? What is element? When I said now this is a column and this is a beam, what's then? Slab. Okay. The loads, we will design a slab first ولا column? صح? Why? Why we are not designing column first? The aim to define the load base route, how the loads, our loads, whatever. Now, I consider myself is a life. I am now consider is your life. This load will transfer to the soil. How can? Yes, when we design, we start with slab, then beam, then column, وبعدين column, وبعدين footing, correct? How the loads will transfer them? This is the first step. We are going to define it. Very simple, conventional system we understand, but a lot of systems. Very time to define the load, how the load will transfer from a structure to the soil. Let us see this slab, and then we will go for slab 1, وبعدين slab 2, وبعدين slab 3. This load, our load, imagine we are here now. And I need you to design beam B3, B1, B1. How the loads will transfer from this slabs to the beam? Perfect. Let us define what is and very important. صح? Actually, we design the slab first. Short direction. Always when you start design the short direction, you're taking the section into 2 meters. يبقى the loads now. The loads will go in one way here, ولا 2 way. Why? Yes, this slab, we are in the slab now. We are existing in the slab, correct? Imagine the same is 4 meter. 4 meter multiply this dimension is 12 meter multiply 4. Imagine. Our loads will transfer to the beams. Which direction? Will go into one direction. It's depend about what? It's depend about length over weights. And we have criteria. That's if L اللي هو length L over B more than 2, يبقى this is what? More 2? One way. One way. Yes, let us see. 8 meter. This is 8 meter or not? Correct or not? يبقى 8 divided what? Divided 2 is equal what? 4. يبقى 100% the loads will go in this direction, correct? وبعدين this slab S2. Why 2 way بقى? Because L over B less or equal to. Less or equal to. يعني this way is يبقى in 2 way direction. 2 ways, huh? Correct? So what about this one? 4 divide 2 way. Correct? This is 45 degrees. Correct? Now we have what? We have two-way. And our exam is coming simple like that. Number one, let's go for number one. Let's go for number one. That's here. 20, 30 seconds. Let us go for number one. Number one. Yes. Load bus is the one of the key consideration. Very important. Number one. Perfect. Number one is a key. How many seconds? Yeah. Okay, طيب حلو قوي. Number two. Let us go for number two. Number two is coming. Number two, how many slabs in number A? In figure A. Figure A. How many slabs? Logically, كده all of them is what? Logically. L over B more than 2. Logically, كده all of them is what? All of them is one-way slab. And the B as well the same, 2 slabs, correct? And the C, لا السي بقى خلاص. C then one the two-way slabs choose L over B more than 2, L over B equal to, L over B less than 2, and choose the criteria. One-way slab, two-way slab. One-way slab, two-way slab. One-way slab, L over B more than 2. خلاص. Once you put in your, even he gave a number. Simple like. Tab number 3. Start. Did we start? Not yet. We are thinking about what? Physical structure and their components. I don't start yet. I'm just talking about how the loads will transfer. Not yet start the effect. The load transfer. We don't for consider the following frame and on the load for this design is what? Is what? Stud and strap, beam, column, footing, soil. D. You all of you 3 over 3. Correct or not? يعني now 3 over 3. 100% يعني. Okay, very good. Easy? Simple? Right. Okay. Let us go for number 4. I'm starting now. Effect of loads. I am starting now. I'm going to start now in number 4. Number 4. I'm starting now the effect of loads. Referring to the figure. what is the location reduces the maximum uplift on a footing. It's effective or not? Correct or not? Now we start effect now. I am talking about before. I'm talking about physical structure and their component. Slab, beams, column. We start to design slabs, then beam, then columns, and whatever, etc. We start now. We'll go for now for a first step. System. I will write it down here, and I will keep still. We have discussed a lot about what is a structure analysis. I will try to tell you, if you have this system, this is a scaffolding system. You can consider it as a scaffolding system. Okay, and we have foundation. This foundation footing A, and this is foundation, and there is bracing system X, and we have footing A. I have here wind load, and I have here what? Life load and dead load. Life load and dead load. In this case, what will happen for foundation A? And imagine kida, if you already change the system and this foundation B, and here is foundation B. What will happen for foundation A? What will happen for foundation A? How? By what? By load? By loads? It's not only load. There is load affecting, and this load, it will develop moment. Where is the footing? Put your finger in the footing. Affected by what? Affected by loads, but it's not by loads. The loads develop moment. This moment, in this case, it will be, this is uplift now. Correct or not? The foundation itself will be uplift from up to left to up to down. Yeah, it will be up to top. If uplift in footing A, what will happen in footing B? If there is uplift in footing A. Yes. If there is uplift in A, sure 100% footing B, it will be overturning in this point. Correct or not? And the both of them is what? Moment. Moment. Okay, type. Moment means what? If you see the line of action, let us see, let us hear about, you remember line of action. This force and this force, line of action, giving you a moment in the same line of action of the wind load or not? Here is a moment, because life plus dead load, life LL plus dead DL, multiply distance. Distance is what? From here to here. Correct or not? X, the center. يبقى now moment يبقى W LL multiply DL multiply distance. Assume this is X. يبقى X multiply X. The same الwind load, but as well it will give you the same line of, يبقى two moment. The two moment, the resultant moment is in the same direction. In the same زائد, of course, زائد the resultant. يبقى now W plus plus, sorry. And wind load multiply what? Multiply y. Multiply y. يبقى now the combination is what? The combination, the two moment in the same line of action. صح؟ In this case صح D. Correct? طيب assume the wind load in this direction. Opposite. What is the combination then? Or this is make you more stable? It will make resultant of moment is equal what? Live plus dead load, live load plus dead load multiply x minus, in this case is minus what? W L multiply L1. Now is a very important is what? Direction. It's in B. In case about here, case A and case B, which one more stable related to these loads? Which one more stable? Yes. It will be more stable, but the cause of overturning is less. If you are extend this foundation more than enough, if you need to more stability, more stable, more equilibrium, and keep it like that. But now overturning will happen here in B. In this case, if you are increasing the size of foundation, it will happen here. The percentage, the probability is 2% or 5%. But here, the percentage is what? 100%. 100%. There is uplifting. And if your foundation is very small, if your foundation A is very small, uplifting and overturning will happen. But if foundation A is big, or there is uplift? No, because the foundation is small. You bought a foundation, very big foundation, it will resist. What we are equilibrium. We are start equilibrium. We will talk about what now? We'll talk about determination. Determination, there is a lot of methods. Force method, displacement method, influence line methods, moment distribution. About physical structure and their component, frames, beams, trusses, columns. This is a physical structure, correct? For each structure system, we have methods. Simply supported. Correct? Truss, frames. Okay, now what is the determination? Determination is the method how we will get all the internal forces values. Then we'll get stress. Determinate about the system. Or the system is determinate or indeterminate. Or the system is determinate or indeterminate. If even determination. As I said to you today, equilibrium message mean what? Sigma x is equal 0. Sigma x is equal 0. Sigma y is equal 0. Sigma moment at any point is equal 0. This is what we call it equilibrium equation. The structure analysis based on that sigma x at sigma x for a structure system itself equal 0. You want the forces in the result of 0. And if y, sigma y, all the vertical forces, the sigma, all the resultant should be equal 0. Sigma moment is equal 0. This is the first standard, and our exam will go for determination, statically determinate, or indeterminate. Never. Why? Because the message is a lot of messages and it takes time. It will take time. Don't imagine that when you have a moment distribution method, you need at least 15 minutes 15 minutes to solve the problem. To come to our exam. Just one case of a deflection. We are going to have it separately. يبقى now, let us go for number 5. Number 4. يبقى now number 4 is 4/4 now. يبقى now is okay. 100%. Number 5 بقى. If 2 engineers solve number 5 in 2 minutes 13 seconds, we'll go for 5-star hotel dinner. We'll go for okay. Forget about equilibrium. Don't forget about equilibrium. Okay. 4/4.